Ray tracing and ray casting, 11 differences. What are the differences between ray tracing and ray casting? Ray casting technology uses raster images with no ray splitting or reflections. Ray tracing, on the other hand, typically refers to that technology that uses the physical properties of light. Are you confused with the technicalities? Well, here are some major differences between ray casting and ray tracing compiled for your better and easy understanding. Read on. Ray casting is a process to create and calculate rays depending on the object it hits, but ray tracing is a process to create them depending on the reflection or refraction path of the ray. Ray casting is a collection of casted and tracked rays based on geometric constraints, but ray tracing is done individually. Ray casting is not recursive, but ray tracing is recursive in nature and is therefore quite slow. Though the ray casting process is faster than ray tracing, it is not as precise as ray tracing, which uses different algorithms and formulas. 1. Creation and calculation. Fundamentally and non-technically, ray casting involves a process whereby rays are created and calculated on the basis of what object it hits, or if anything it hits at all. On the other hand, ray tracing involves a process where the rays are created and its path is traced on the basis of its reflection or refraction after hitting an object and all through the scene. This process allows determining the type of light that may arrive at the source from the other way. 2. Principle. In ray casting, the rays are cast and tracked as a collection based on particular geometric constraints. For example, for a 320x200 display resolution, only 320 rays are traced in ray casting because there are 320 horizontal pixel resolutions in the display. On the other hand, in the ray tracing technique, every ray is traced individually so that every pixel or point on the display can be traced by a single ray. For example, for a 320x200 display resolution, a total of 320x200 equals 64,000 rays are traced by the ray tracer. 3. Nature. The ray casting process is not recursive in nature because the engine stops when a ray hits an object for the first time. It then uses an ordinary lighting model to find out the incoming illumination empirically. Therefore, in essence, ray casting is ray tracing but without any child rays. On the other hand, ray tracing is recursive, which is why it is slow. This means that recursive propagation is created for several other rays by a specific ray shot out from the viewing position through the viewing plane. It helps in determining the illumination of the point that has been intersected primarily. 4. Method. In the ray casting method, what is hit by a single ray segment is found out. Therefore, in simple words, it is nothing but searching the hit incrementally all along the ray from the eye. On the other hand, ray tracing is a process where numerous ray casts for each pixel are required. Typically, it is calculated by using an equation directly. 5. Formula precision. The formula used in ray casting is not exact in most of the cases. On the other hand, the formula or algorithms used in the ray tracing technique are pretty accurate in most of the cases. 6. Speed. The ray casting process is much faster in comparison to ray tracing since it needs to trace less number of rays. This makes it very useful for real-time processes. On the other hand, the ray tracing process is much slower in comparison and is therefore not suitable for real-time processes. According to the above example, it is about 200 times slower than the ray casting process. 7. Constraints. The raycasting process can be carried out only on simple geometric shapes due to its one or more geometric limitations. On the other hand, ray tracing techniques can be followed to render images of almost any shape. 8. Storage. In the raycasting process, the images that are finally rendered are not stored on the disk. Typically, it stores only the map, and as for the corresponding images to those maps, these are normally produced on the fly. On the other hand, all the images that are rendered in the ray tracing process are typically stored on the disk and are loaded as and when these are required. As of now, there is not too much hardware available that is fast enough to render the images after ray tracing on the fly. 9. Number of rays. Usually, in raycasting there is less number of rays to trace due to a few geometric constraints. Typically, this particular technique is actually an implementation of ray tracing with a special purpose. On the other hand, there are lots more rays to handle in ray tracing that may come from all possible directions and also move in different ways after hitting an object. Therefore, it is a much more complex technique. 10. Secondary rays. In the raycasting process, no secondary rays are used. This means that these specific features are either not employed or, if they are, it is done by using some other types of algorithms, which probably are more inaccurate. On the other hand, in the ray tracing process the secondary rays are used. These rays typically help the ray tracer to compute particular shadows, reflection, refraction, and the probable indirect illumination. 11. Quality of images. The resulting images in the raycasting process are not very realistic since it does not take reflection and refraction of light into account. Therefore, the images are often displayed in blocks. On the other hand, the images rendered via ray tracing technique are very realistic, often too realistic with shadows and reflection clearly displayed.